So now we're going to do some examples in radians. Radians are always just a little bit, take a little bit longer to get used to. So let's start with the first one, pi over 3. Pi over 3 is an angle in the first quadrant. So I can draw it in the first quadrant. That means my theta is equal to pi over 3. So from that chart in the beginning, we know that in the first quadrant, whatever my theta is equal to, that's what my reference angle will be equal to. So my reference angle in the first quadrant is pi over 3. So first quadrant reference angles are always the easiest. Now we have 6 pi over 7. 6 pi over 7 lies in the second quadrant. I know that, and one way that you can remember that, if I look at, this is really 7 pi over 7, or pi, that means that 6 pi over 7 is just one less, so it's in the second quadrant. So this is 6 pi over 7. If that confuses you, you can always convert back and forth between degrees and radians, like we learned before. So now I need to find my reference angle. My reference angle is always the terminating side back to the x-axis, not the y-axis, the x-axis. So this is my reference angle here. So how this is actually easier is I always just have to look at this part of my theta, and that will be what my reference angle is. Because if I think that this is 6 pi over 7, and 180 degrees is 7 pi over 7, we know that in the second quadrant, to find our reference angle, my reference angle is going to be pi minus my theta, which is 6 pi over 7. Well, that's really 7 pi over 7 minus 6 pi over 7, which gives me pi over 7. So my reference angle here is equal to pi over 7. Or you can just look at this, and it's the denominator and the pi. That's really the easiest way to look at that. So I have a third quadrant angle now, 5 pi over 4. 5 pi over 4 is going to lie in the third quadrant. So this is 5 pi over 4. I know that because this is going to be 4 pi over 4, and I'm a little further than that, so I'm at 5 pi over 4. The reference angle is going to be the terminating side in the x-axis, so here's my reference angle. I know in quadrant 3, we're always going to take, to find the reference angle, we're going to take the theta, which is 5 pi over 4, and subtract pi. If I get common denominators, that's going to be 5 pi over 4 minus 4 pi over 4, which gives me pi over 4. So you can see, once again, it's just, usually it works out pretty nice that it ends up just being the denominator and the pi. So my reference angle is equal to pi over 4. Lastly, we have a fourth quadrant angle. So this opens up in the positive direction. We come here. This is a fourth quadrant angle. I know that it's the fourth quadrant because this is 2 pi, and 2 pi can be written as 12 pi over 6. Well, 11 pi over 6 is a little less than 12 pi over 6, so it lays in the fourth quadrant. So my reference angle is going to be the terminating side and the x-axis. That means my reference angle is going to lie in here. So I know in the fourth quadrant, to find my reference angle, it's going to be 2 pi minus my theta. If I get common denominators, that's 12 pi over 6 minus 11 pi over 6, which gives me oops, I wrote that wrong, which gives me pi over 6. So once again, it ends up being the denominator in the pi. So my reference angle here is pi over 6. So I just want to take a minute and show you how to do this with negative angles really quick. So if I have negative 440, so I got to think about where that's at. So if I'm going in the negative direction, this is negative 0, negative 90, negative 180, negative 270, negative 360, and then this is negative 450. So if I think of 440, it's going to go around and come down here. So I'm here at negative 440. My reference angle is this distance here. And my reference angle is always positive. So I really want to say, how far did I go from 360 to get to 440? That's kind of how I think about it. I think about it as a distance. So how far did I go from 360 to get to 440? My reference angle here is going to go from negative 360 minus 440. So it's going to be negative 360 minus a negative 440, sorry, plus 440. So that's going to give me 80. So my reference angle here was 80. So I take, to find the reference angle in the fourth quadrant, it's the reference angle is equal to, since we're going in the negative, it's going to be negative 360 minus my theta. So that's what I did here. And lastly, we're going to do another one here. If I want going negative 7 pi. So if this is 0, I'm going into the negative direction. This is negative pi. So I start at 0, negative pi, 2 pi, negative 3 pi, negative 4 pi, negative 5 pi, negative 6 pi, negative 7 pi. So I land on an axis. When I land on an axis, I don't have a reference angle. So there's no reference angle here. So whenever you land on an axis, either the x-axis or the y-axis, you do not have a reference angle. And that's kind of a special case. So this is a special case when you land on an axis.